Hello everyone, this is Mr. McMillan and I'm here with the example problems from page 6 that we covered in class on the applications of the Pythagorean theorem. Okay, so the reason that I'm doing these are 8 practice problems, and these are problems that you would be and the wordings would be very likely to see on a quiz or a test or something along those lines, okay? So make sure that you're paying attention, especially for what, for each one of these, because the wording can sometimes get tricky, so you need to make sure that you understand how exactly to find the wording that you need to find and how exactly to find the information in the problem that you would need to solve the problem, and importantly what to do in order to solve the problem. So let's look at number 1. Number 1 says, for the triangle below, what is the length of AC, of line segment AC? So it explicitly states what is the length of AC. And so anytime you see something say what is, it's good if you don't already have something on that line or on that segment or on that slope or whatever, that you go ahead and put an X. So here we have AC and it has nothing on it, so we're just going to go ahead and put an X on there so we can solve this. Okay, now it says for the triangle below, what is the length? So we're trying to find X that we've put on here, and specifically we have a right triangle here, and we can tell we have a right triangle by the corner marking, the little box in the corner at angle B. So we have a right triangle here, and we know 2 of the other sides, so that means we can use the Pythagorean theorem. Remember, you have a right triangle and 2 sides, that means you can find your third side. So next up, are we looking for a leg or are we looking for the hypotenuse? Well, if we look here at X, we see that X, the side X is on, does not touch the right angle whatsoever. So that means it's opposite of it, which means that we are dealing with the hypotenuse. That's what we're trying to find. And if we're trying to find the hypotenuse, which letter would we use? A, B, or C? Well, we would be using C. So X is our C value. Remember that A is your short leg value typically, and B is your longer leg. Your Pythagorean theorem is A squared plus B squared equals C squared. And so here you have A squared. Well, we said A was 8. So we've got 8 squared plus, and then we have B squared is 15, so 15 squared. And we don't know what C squared is, it's just the X, so this is just X squared. All right, now we're going to simplify and solve for X. So we have 8 squared is 64, 15 squared is 225, and the X squared drops down. The X squared's already by itself, so we don't have to move anything over. So we just take 64 and add 225, which gives us 289. So 289 equals X squared. Remember that we have to find out a way to cancel out that squared that's with the X. And the way we're going to do that is do the opposite operation of a square. And when you square a number, the opposite of doing that is to square root it. So we're going to square root X squared, but what we do to one side, we've got to do to the other. And so the square root canceled out on the right side, and that gives us X. And the square root of 289 gives us 17. So we know that 17 is equal to X. So AC is 17. So number 2, it says for the triangle below, what is EF? Now here's the thing, whenever it says what is and then you see like a line segment, but it doesn't have that bar here. This stands for the length of whatever the line segment's name is. So this is the same thing it's asking here, just with a different set of, or just worded a little bit differently. Okay, so we say, what is EF? And so if we look for EF here on this triangle, we see that EF does not have anything on it. So we're going to put an X on it there. Okay. Then we're going to look for our A, B, and C values. Well, if we look here, E is our right angle, our right triangle. So the side opposite from it would be our longest side, our hypotenuse, which is labeled with C. So if we look at our opposite side is 9 root 2. So that's our C value. Then our A and B value, it's hard to tell which one's longer and which one's shorter. So we're just going to say that X is A and 9 is B. So now we have our Pythagorean theorem to figure out what the missing side length is, which is EF. So we've got A squared plus B squared equals C squared. A squared would be X squared. B squared would be 9 squared. And C squared would be parentheses 9 root 2 parentheses squared. Okay. Well, we can't do anything with the X squared, so we just drop it down. 9 squared is 81. And if we go on the Desmos and do 9 root 2 squared, nine root 2, and then square it, we get 162. Okay. X squared plus 81 equals 162. We have to get the X squared by itself on that side. So we're going to subtract 81 from both sides. And we get that X squared is equal to 81. And again, just like the previous problem where we need to get rid of this squared, we need to square root both sides. The square and the square root cancel. And that leaves us with X is equal to the square root of 81. And the square root of 81 is equal to 9. So that means that EF is equal to 9. Number 3. Number 3 says, given the two leg lengths of a right triangle are 17 and 23, determine the length of the hypotenuse. Round your answer to the nearest tenth. So it says, given the two leg lengths of a right triangle are 17 and 13. So it tells you the leg lengths are 17 and 23. So you already know what A and B are. A is 17 and B is 23. It then says to determine the length of the hypotenuse. And the hypotenuse is always represented with the letter C. So C is equal to question mark or X or whatever you want to say. Okay. So since this is a right triangle, we can use A squared plus B squared equals C squared to determine our answer. A squared plus B squared is 17 squared plus 23 squared. And we don't know what C squared is. Okay. Let me pull up my calculator here. I'm just using the basic one. I don't need much more than that. You can use Desmos if you want. So 17 squared will give us 289. 23 squared will give us 529 equals C squared. On the left side, we need to combine 289 and 529, which is 818, is equal to C squared. And then what we need to do, because again, we need to get rid of that squared, we need to square root both sides. On the right side, the squared and the square root cancel out, so we get C equals, and if we take the square root of 818, we get this decimal, and we want to round our answer to the nearest tenth, so remember, nearest tenth is 1 decimal place, so that would be 28.6. So our hypotenuse would be 28.6. All right, oops, sorry. Number 4, which of the following sets of side lengths below would form a right triangle? So you're looking to see which one would form a right triangle. Now this question could be worded a few different ways. It could also ask you for an acute triangle, or it could ask you for an obtuse triangle. Okay, so you need to make sure that you pay attention to which one it wants you to determine it is. And only one of them, if it gives you multiple choice, it should only give you one. Now, sometimes you may get one that says find all or determine which side lengths would form an obtuse triangle, select all of them or whatever else. But for most part, it'll be multiple choice. So let's look at this. We need to see which one of these 4 options would determine a right triangle. So let's look at this. So we've got 9, 37, and 43. So again, we need to see if a squared plus b squared equals c squared, okay? So what we're going to do here is do our a, b, and c. In choice A, we have 9, 37, and 43. So our c value would be 43. So we know that 9 squared plus 37 squared, is it equal to 43 squared? And if we do that in our calculator, we can see 9 times 9 is 81. And then we have 37 times 37 is 1369. And we have 43 squared as 1849. So now we have this. If you add 81 and 1369, is that equal to 1849? The answer is no. So A cannot be a right triangle. So let's look at B. We've got 20, 22, and 28. 28 is our largest side, so it's going to be our c squared value. So we have 20 squared plus 22 squared. Is it equal to 28 squared? Well, let's find out. 20 squared is 400. 22 squared is 484, I think. Yes, 484. And 28 squared is 784. If you add 400 and 484, do you get 784? No, you do not. You get 884. So B is not a right triangle either. All right, so C, 9, 8, and 21. 21 is our C value, so we have 9 squared plus 18 squared. And is it equal to 21 squared? Well, 9 squared is 81. 18 squared is 324. And 21 squared is 441. And when we add 81 and 324, does it give us 441? No, it does not. So that means that D has to be the answer because it's the only one left unless I made a mistake, which is, absolutely within the realm of possibility. So let's look and make sure and check. So C would be 25, A and B would be 7 and 24. So 7 squared plus 24 squared. 7 squared is 49. 24 squared is 576. And 25 squared is 625. Then we add 49 and 576 together, and it gives us 625, which is equal to 625. So D is indeed the right triangle. Thankfully, I didn't make a mistake. All right, now let's look at number 5. And every single person that just looked at number 5 is groaning because it's a word problem. So it says John needs to remove a piece of furniture and needs to place it in a truck outside the house. He plans on using a ramp to make it easier to move it onto the truck. The back of the truck is 72 centimeters tall, and the ramp is 128 centimeters long. What is the horizontal distance from the end of the ramp to the back of the truck? Round your answer to the nearest tenth of a centimeter. So that's a lot to unpack, but the key thing here is that we want to know the dimensions that we're looking at here. Okay, so it says the back of the truck is 72 centimeters tall. If something is tall, is it laying on the ground, or is it standing up straight, or is it diagonal? It would be vertical, because you're talking about the height, right? When you take your height, you don't do it laying down, you do it while you're standing up. Okay, so the back of the truck is 72 centimeters tall. Okay, so we've got a 72 centimeter tall bit here. And the ramp is 128 centimeters long. Now, if you've ever seen a ramp, which way does a ramp go? Does it go vertical, horizontal, or does it go diagonally? And the answer should be that it goes diagonally. If your ramp goes anything other than diagonally, rethink your use of a ramp. Okay, so we have a diagonal ramp here that's 128 centimeters long. So we know that the ramp is 128 centimeters long. And it says, what is the horizontal distance from the end of the ramp to the back of the truck? So we're looking to find that missing side. Okay. And you should know that this would form a right triangle, where 72 is one of your legs and 128 is your hypotenuse. So since 128 is your hypotenuse, you have C there. Then 72, you have A, and your other side, you don't know what it is. So that's going to be your B. So we can use the Pythagorean theorem, a squared plus b squared equals c squared, to find our missing side, which is b in this case. A squared would be 72 squared plus b squared equals c squared is 128 squared. So then 72 squared, got it covering up the screen, I'm sorry. So 72 squared would be 5184 plus b squared equals, and then 128 squared is 16,384. We need to get b squared by itself. So to do that, we subtract 5184 from both sides, and you get b squared equals 11,200. To get rid of the squared, we need to square root both sides, and you get that b is approximately 105.8 centimeters. And the reason we rounded it to the nearest tenth is because it wanted us to round to the nearest tenth. Okay? So the distance there is 105.8 centimeters approximately. All right, now let's look at number 6. Number 6. Number 6, it says that Sally is making a garden planter with wood in the shape of a right triangle as shown in the drawing below. What length of wood would complete her garden planter? So she has 2 pieces of wood here already placed. And we need to know what that third piece of wood would need to be in order for her to complete that garden planter. So in other words, are we looking for the leg or are we looking for the hypotenuse of that right triangle? Well, if we look here, we see that the 2 sides that are touching that right angle are already there. So we already have our legs. So that means we're looking for our hypotenuse, which is C. Our shorter leg is 36, so we'll have that be A. And our longer leg is 48, which will be B. So now we can use the Pythagorean theorem to figure out what our missing length is there. And so we have A squared plus B squared equals C squared. So we have 36 squared plus 48 squared equals X squared. So 36 squared is 1296. 48 squared is 2304. And that's still equal to X squared. Combine 1296 and 2304, and we get 3600 is equal to X squared. Square root both sides to get rid of the squared. And when we square root 3600, we end up with 60 inches is equal to X. So she would need a piece of wood that would be 60 inches long to complete the planner as it's shown there. Okay. All right, number 7. So we're on the last two here. Number 7, what is the length of the diagonal of a rectangle that is 16 feet wide and 63 feet long? Okay, so 16 feet wide, 63 feet long. And we're looking for the length of the diagonal. Okay. Well, if it's 16 feet wide, we have a diagram here. Wide typically refers to up and down when we have it drawn out like this. At least that's the way I've always done it, and length is always from left to right. It doesn't really matter in the long run, but in this case, I'm going to label it as such. So it's 16 feet wide. So it's 16 feet on both of those sides, and it's 63 foot long on the others. Okay. And what it wants us to do is find the length of the diagonal. Well, when we talk about rectangles, we know that the angle measure of all of the corners on a rectangle is what? Well, all these angles should be 90 degrees. So that means that every rectangle can be split by the diagonal to make 2 right triangles. So all we're going to do is focus on one of these, okay, this one right triangle here. So we want to find the length of the diagonal, which is our hypotenuse. So we know this is C. Our short leg is 16, and our long leg is 63. So then we take A squared plus B squared equals C squared. A squared plus B squared is 16 squared plus 63 squared equals X squared. 16 squared is 256. 63 squared is 3969. 3969 plus 256 is 4225. Square root both sides, and you get that X is equal to 65. So 65 feet is what X would be. So the length of that diagonal would be 65 feet. And then our last one, number 8. What is the length of RS? Now, if you look here, we have a triangle here that has been split down the middle by this line here, okay? And this is important. We know that this line here is 12, this line and these two lines are 13, okay? So we want to figure out what RS is, and RS is this whole thing, right? But with the information we have, can we figure out what the length of that whole thing is? Well, if you look at this problem here, do you notice how these two triangles are both right triangles? Well, if these two are both right triangles, that means that if we have two of the sides, we can find the third side. Now, granted, the whole side won't be found immediately because it's only part of it, but if we find both parts, we can find what the whole thing is, right? So let's look at that. We've got 13, 12, and 13. So we're going to cover up this. And are we looking for a leg or are we looking for a hypotenuse? Well, on this one, we're looking for our short leg A. And we know that B is 12 and C is 13. Now I am going to point out, since these two sides are the same length, then this is going to be whatever this ends up being. So we'll know this part already. So we're going to solve for a squared plus b squared equals c squared. We don't know what a is. B squared is 12 squared, and that should be equal to 13 squared. A squared drops down. 12 squared is 144, and 13 squared is 169. Then we subtract 144 from both sides, and we get that a squared is equal to 25. Square root both sides, and we get that a is equal to 5. And that's what both of these are. Now, since RS is the length, or is that whole entire length, we have two segments here that split it up, and they're both measure of 5. So RS is equal to 5 plus 5, which is 10. Okay. All right. So what I want you to do, I want you to work on Q.1 to a score of 50 on IXL, Q.2 to a minimum of 90, I believe, and Q.3 to a minimum of an 80. So work on those, and everything should be good as far as that goes. And we will continue covering this on Thursday with some more practice problems, and then talk about special right triangles either Thursday or Friday. Okay. If you do have any questions about this, please make sure that you ask. I can only help if you ask me. That way I know exactly where you're having issues with the content. Thanks, guys, and I will see you in the next video.